Okay, we're going to begin with explaining how to find confidence interval for the population proportion. Proportion means a percent. So I'm going to begin with question number 1. A survey of 500 non-fatal accidents showed that 142 involved uninsured drivers. So out of 500 non-fatal accidents, it happened that 142 of those were uninsured drivers who were driving without car insurance. Construct a 99% confidence interval for the proportion of fatal accidents that involved uninsured drivers. So we have information from the sample. We need to generalize, to the entire, just population of all non-fatal accidents. Here's how we begin. First of all, we find what we call the sample proportion. It's the percent of non-fatal accident that involved uninsured driver. So it's 142 out of 500. You just divide those two numbers and you get 0.284, which is 28.4%. This is called the sample proportion, and this is called also an estimate and point estimate of the population proportion. Now, if he asks you to verify the requirement of the test before you find the confidence interval, here's how you verify that. You need to verify, this is called the P with the hat on top of it. You need to verify that n times P of P hat times 1 minus P hat is greater than 10. N is the sample size, which is a 500. So just put 500. 0.284 is P hat, and 1 minus 0.284, they call it Q hat. P hat is called the probability of success, and Q hat, which is 1 minus P hat, is called the probability of failure. If you guys multiply those three numbers together, you get 101.672, which is of course greater than 10. So we're ready to find the confidence interval. Now, what is a confidence interval? The confidence interval is a range of values with a lower bound from the left and an upper bound from the right, where we think with some high confidence level, where we think that the true population proportion will be between those two bounds, the lower bound and the upper bound. Let me show you how we can use Statcrunch to find this confidence. Okay, ready? First step, you go to Stat, Proportion. If he asks you to find a confidence interval for the proportion, this is the only feature right here. It says proportion stats. We're working in this chapter only with one sample and only with the summary, so with summary. Number of successes. We have 500 accidents, 142 of those involved uninsured drivers. The 142 is the X value, which is the number of successes, so we'll put 142. Number of observation is the sample size, we'll put 500. And then look here, confidence level, and what confidence level he wants, 99%. So just change it to 0.99 and hit compute. And let me show you the interval right here. This is the lower limit, 0.232. And this is the upper limit. If you want to round to 3 decimal places, it will be 336. Let me take you back to the document, show you what we have. P, you don't put P hat. P hat, we already know what P hat. It's about population proportion. 0.232, and it's less than 0.336. What's more important, guys, that you know how to interpret this answer in words. So here's how you interpret. You say, with 99% confidence, you can say, or you can say, we can say that the true proportion of non-fatal accidents, sorry, should have been non-fatal accidents. Non-fatal accidents involving uninsured drivers is between. I would change, when you write a statement for a reader, I would change the decimals to percents to between 23.2% and 33.6%. So this is how you construct confidence interval for the population proportion. You need always three things, guys, to do that. You need the sample size or the number of observations, n. You need the number of successes, which is x. In our case here is 142. And you need the confidence level, and you should be able to create any confidence interval. This is the first part of this section. Now I'm going to walk you through the second part of this section and how to find the minimum sample size required to construct a confidence interval where the margin of error will be given. So let's do the next question. A state highway patrol official wishes to estimate the number of legally intoxicated drivers on a certain road. How large of a sample is needed in order to be 95% confident? So the confidence level, guys, here is 95%. That the sample proportion will not differ from the true proportion by no more than 2%. The difference, guys, between the sample proportion and the true proportion means population proportion, is called the margin of error. So he's given us the margin of error E equals 0.02, 2%, change it to a decimal. Now, I will provide this formula if you need it, and this is the formula to find the sample size when working with proportions. N is P hat times Q hat. You can replace a Q with 1 minus P times Z square, ZC square, which is the critical number given the confidence level, which I'm going to show you how to find it, and divided by E square. Okay, here, guys, he gave me E, which is 0.02, so I'm going to put it right here. He didn't give me Z, but he gave me the confidence level. I'm going to show you from the confidence level how to find, ZC. So watch. We come back to Statcrunch. We go to Stat, Calculators. So to find the critical number Z, this is how you do it. Calculators, normal calculator. You choose in between. And you put the area, the confidence level right here, 0.95. That's what we have in the question. And watch and see, guys. Okay. The red area is called the confidence region, which is 95%. The remaining area in the two tails is the 5%, 2.5% here and 2.5% there. This number, guys, that splits up the two areas right here and right here is called the critical number, which we already found using Statcrunch. It's 1.96. We have a negative 1.96 sitting right here, and we have a 1.96 sitting right there. If instead of 95%, he gives you 90%, and he asks you to find, just a critical number, you just put 90 right here and compute, and look, you get the two numbers. 1.645 here and negative 1.645 there. And if he gives you 99%, these are the three common confidence levels. Watch. It's negative 2.576 and 2.576. This is 2.576 here, and this is negative 2.576. In our area, guys, in our question, it's 95, so it's 1.96. Let's take you back to the Word document. Okay, so I put 1.96 here, and I put 0.02 there, square. Now, he didn't give me information about the sample proportion. If he doesn't give you any information about the sample proportion, you will use 0.5 for P hat and 0.5 for Q hat, or 1 minus P hat. And if you do the math, you will get 2,401. So the minimum sample size required is 2,401. Now in part B, he says repeat part A, but this time he's going to give us information about P hat. Assuming previous studies found that 75% of the drivers on this road were legally intoxicated. So this is a P hat given to us, so we're not going to use 50%. We're going to use 75% for P hat. But what is a Q hat? Q hat is 1 minus P hat, so it will be 25%. And then, guys, same thing here. I just copy it and paste it right here. And I got this answer, 1,800.75. Remember, a sample size cannot be a decimal, so you always have to round it up. Look, round up to the next integer, next whole number. So what's the next whole number after 1800 will be, the minimum sample size will be 1801. This is everything that you need to know about finding confidence intervals for the population proportion. One more thing I would like to mention here, if he gives you the interval and he asks you to find the margin of error, for example, so going backward, look what you can do, guys. Subtract the lower bound from the upper bound and divide by 2. So the margin of error E will be 0.336 minus 0.232 divided by 2. If he asks you to find a p hat given the interval, that's the sample proportion. Look what you do, guys. You add 0.232 to 0.336 and you divide by 2. If you do this one, you're going to get 0.284.